An inequality compares two expressions using less than, or equal to, or greater than and equal to. An example is 5 is greater than 3. An inequality that contains a variable is an algebraic inequality. An example of this is c is less than or equal to 12. A solution of an inequality is any value of the variable that makes the inequality true. All of the solutions of an inequality are called the solution set. For a linear inequality, you can graph the solution on a number line. The symbols less than or greater than indicate an open circle. Less than indicates drawing an open circle and then shading to the left, while greater than indicates drawing an open circle and then shading to the right. The symbols less than or equal to and greater than or equal to indicate a closed circle. Again, if it is less than or equal to, then you draw a closed circle and shade to the left, and it is greater than or equal to, then after drawing a closed circle, you shade to the right.
Okay, I will show you how to graph points. So your graphing points are on the Cartesian plane, which is just the y-axis and the x-axis. So every point has an x value and a y value. So to graph this point in 3, 4, we'd go to the x value 3 and the y value 4. And there's our point. So now let me show you how to graph equations. We'll try to graph y equals x plus 1. So I'll plug in some reasonable x values like -1 and 1, and then I get the y values 0 and 2. So these are my points, -1, 0, and 1, 2. So I'll graph these. Then I connect them with a ruler. So this is how you graph an equation. Now let me show you how to graph an inequality. So if this equal sign wasn't an equal sign, if it was, say, less than, then first of all we need to make this line dashed because the line isn't a solution to this. It has to be less than the line. So then we would shade all the area that's below the line as a solution set. So if it was greater than, then we'd shade above it. And if it was less than or equal to, then the line would actually be a solution. So it wouldn't need to be dashed. Also, if it was y is not equal to x plus 1, y is not equal to x plus 1, then we would just make the line dashed because that's not the solution, and then just shade everything else.
I will show you how to graph systems of inequalities. I've already graphed the lines y equals x plus 2 and y equals negative 2x. For the inequalities, y is less than x plus 2, we expect to shade under the line. Let's test that with a point 0, 0. Yes, so we shade under. For the inequality, y is greater than or equal to negative 2x, we can test with a point, we expect to shade above. Let's test with a point 1, 1. Yes. The solution area is the red and green area. Let's emphasize it. All the points in this region will satisfy both the red and the green inequalities. You can also do this with 3 or more inequalities. What if you have 2 parallel inequalities? We saw with the equations that if you have 2 parallel lines, there won't be any intersection, so there's no solution. With inequalities, if you shade in 2 directions, there won't be any solution either, because they do not overlap. In this case, you would write no solution, or the empty set. If you shade in the same direction, like with y is less than or equal to x plus 1, and y is less than or equal to x minus 1, the solution set will be the solution set of y is less than or equal to x minus 1.